The other question we consider today comes from actually the exam. This is Cambridge Assessment International Education, Cambridge International Advanced Subsidiary and Advanced Level. This is paper 1, pure mathematics 1. The code is 9709/13, which was taken October/November 2023. And we are interested in question 7. Question 7. Yeah. So question 7 reads, the function f is defined by f of x is equal to 1 plus 3 over x minus 2 for x greater than 2. State the range of f. That's 1 mark. B, obtain an expression for f for inverse of the function f of x and state the domain of the inverse. 4 marks. The function g is defined by g of x is 2x minus 2 for x greater than 0. But C, obtain a simplified expression for g f of x, composite function. That is 2 marks. Yeah, so that's the question, and let's straight away see our solution. Well, let's look at the solution to that. And we are told that the function f is defined by f of x, is equal to 1 plus 3 over x minus 2 for x greater than 2. For x greater than 2. So Roman 1, state the range of f. Now, for us to find the range, because normally what we should remember when dealing with functions, we are more interested in the domain and the range. So in this case, we want the range, state the range of f, that is this particular function. So to find the range of that function, so we'll see that first we want to consider what x can do. Because here we see that x is greater than 2. And if x is greater than 2, then we want to see exactly what the behavior of x is. So let's see. If I take x to be 2 here, if I take x to be 2, then I'll be having a 0. The result of that already tells me that the function f of x in that case will be infinity. That's unbounded. So what we'll see is that x has the freedom of taking any other value which is greater than 2. And so it can go on and on until it gets to infinity. Of course, positive infinity, because it's moving towards the positive side. So we'll say as x, we just say as x approaches, that means that it's approaching 2 from the right. So putting this means that x is approaching 2 from the right, as in if we draw our curve, we are coming that way. Yeah. So then so that means that x can increase to an extent where it is a value which is so big. And in that particular case, the bigger x goes, the interesting thing is that when x is 2 here, when x is strictly 2, the f, so when x, it's supposed to be greater than 2, but not 2. But we should observe that when x is strictly 2 in this case, then f of x The behavior of f of x is infinity, positive infinity. That's when x is when x is strictly 2, because if you substitute 2 here, you'll be having to divide 3 by 0. And dividing a number by 0 means you are going to end up with a very big value, very big, and it's infinity. Now, for x is greater than 2, let's take x is 3. When we take x to be 3, then f of x will be 4. Okay. When x is 3, f of x will be 4. Will be 4. Because it's 1 plus 3 over 1, which is 4. But let's see. When x is now 4, f of x becomes, when x is now 4, it means now we are dividing 3 by 2. So it's going to be 1 plus 1.5, which is 2.5. It's going to be 2.5. Now, see that as we increase x, this reduces, the function reduces. As we increase x, the function reduces. So what we can say here is that, and so we say, so f of x is approaching infinity, a case where we take, when it is 2, when this is 2, when we take that to be 2. And as x approaches infinity, 3, as x approaches infinity, that is this, as it approaches infinity, the function f of x, specifically not really the function, if I treat this as a constant part of the function, this, then I would take the variable part. So the variable part, which is 3 over x minus 2, as x approaches infinity, this will approach 0, as we have seen, because the x will be very big. X will be very big, yeah. As x approaches infinity, x will be very big, and the quotient will be approaching 0, yeah, right. That's what it should be. So, in this case, f of x is 1, they say. In that case, f of x is 1. When that happens, f of x is 1. Thus, f of x can take the values greater than 1. F of x, now we are referring to f of x, not x. X we have seen taking these values greater than 2. But we are saying f of x itself, because we see that there is a portion of f of x. This portion here is variable because it depends on the value x. But there's this part here which is constant. So we are saying in the event that this varies as much as it wants, when it's approaching 0, f of x will find it to be 1. And if that is the case, then we say, but never exactly 1. But never exactly 1. Why are we saying never exactly 1? We are saying never exactly 1 because at least it will be some value. And if it is some value, then the quotient will be approaching 0 but not 0. And so if it's not 0, you'll have to subtract it from 1. And the value f of x in that case will not be 1. So that's what is understood. Yeah, because this will only approach 0 if this is big. And in which case, this quotient has some value, however small it is, however small the value will be. that small value, if you're supposed to add. Now that small, so we say, okay, what did I say? But never, okay, thus f of x can take values greater than 1, yes? Greater than 1, yes? Yeah, greater than 1, but never exactly 1, yes. Never exactly 1 because of that particular aspect, yes, this. So there will be 1 here plus the value that you get here. However small the value is, it's not 1. So that's what we are saying. Therefore, the range of f in that case will then be 1 and infinity. 1 and infinity. 1 and infinity. That's the range of f. We are asked the range of f, that's the range of f, because it is a function of this, made up of the variable part and the constant part, where the constant is 1. And as x approaches infinity, the whole quotient approaches 0, but never really being 0. It's never really being equal to 0, but it's so small approaching 0. So in that case where it's approaching 0, we'll be having f of x. If it approaches 0, if it indeed approaches 0, it becomes so large that it gives us a value 0, then in that case f of x is going to be 1. But we also see that however much it is changing, we are not considering this possibility. Okay, we are not seeing a situation where x is going to be exactly 0 and not very small. Infinitesimally small, something like that, very small, very small. So in that case, we see that x will not just be 1, but it will be 1 plus some value. However small that value is, f of x is not 1. So we say here, in this particular case, and that's why we give it this. We give it the round bracket to mean that 1 is not included in that boundary, and this is also infinity. This again, we are not defining where it's stopping, but it's a very big value which can still behave in a very large way in that particular dimension. Well, that's that. Obtain an expression for f inverse of x and state the domain of f inverse. So we are supposed to obtain an expression for f inverse of x. F inverse of x. So f inverse of x, we will be having f of x is equal to 1 plus 3 over x minus 2. That's what we have. 1 plus 3 over x minus 2. And essentially this is y is equal to 1 plus 3 over x minus 2. And we can change this. Now I want to get f inverse. To get f inverse of x, I have to first define what x is. So to make x the subject, I'll be having 3 over x minus 2 is equal to y minus 1. Is equal to y minus 1. And this should then mean, that x minus 2 into y minus 1 is equal to 3. Is equal to 3. And so x minus 2 is equal to 3 over y minus 1. That then will mean that x is 2 plus 3 over y minus 1. Therefore, f inverse of x will be 2 plus 3 over x minus 1. That's it. F inverse will be 2 plus 3 over x minus 1. So that takes care of part B. Yes, that takes care of part B. So yes, and so we move to part C. We move to part C, and we see that the function g is defined by 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 g of x is equal to 2x minus 2 for x greater than 0. For x greater than 0. So we are asked to obtain a simplified expression for g f of x. A simplified expression for g f of x. So that then means that we first had that f of x is this, and g of x is this. So the procedure of having that is that we'll now substitute in g so we say g f of x will be 2 first let me now it's 2, but where there is x we put which expression is this? Where there's x we put this 1 plus, now we put this f of x because we want g, actually that's a composite function, so we want g f of x. So where in place of x here we put this, so I'll be having 2 into 1 plus 3 over x minus 2 like that, and this is 2 plus 6 over x minus 2 minus 2, which is 6 over x minus 2, which is 6 over x minus 2. So that becomes the simplified expression, and we are saying that is what is equivalent to g f of x, and that's the answer. So if you follow that procedure up to here, you should be in a position to score full marks. So up to there, kindly follow me to my next video.